So we're going to look at active transport, which was a question that some of you had a bit of difficulty with. The question showed that a chemical was added here and that prevented respiration. And as you can see, if you look at the y-axis here, that the rate of uptake of a mineral drops off very quickly, and the clue is then that if there's no respiration, there's no energy required, and that suggests really that active transport is involved. So what we need to know, of course, is what do we mean by active transport. A good analogy for this, I think, is if you think about a dam, and you think on one side of the dam you have a very high concentration. In this case it's water, isn't it? So we can use square brackets to represent concentrations. We've got a high concentration here, and then on the other side of the dam it's low. So what will happen naturally, of course, is the water is going to flow this way from a high to a low concentration. I didn't want to do that. Okay, so it's going to flow from high to low. Now if you imagine you wanted the water to go the other way, and imagine you had to carry the water up the other way from a low concentration to a high concentration, I think you can get the idea that you're going to need a lot of energy to do that. So if you're going to do that, you need to employ what's called active transport. And active transport requires energy because you're taking the particles from a low concentration to a high concentration. And you probably just need to know a couple of examples. Here's the first one that comes up quite a lot. This is a root hair cell in a plant, and the problem is there's often a greater concentration of minerals of some sort. Let's imagine they're kind of nitrate ions or something like that. I'll put them in here. We've got lots of nitrate ions in here that you'll remember the plant needs for making proteins. Now of course they should just diffuse out, shouldn't they? But what will happen is we still need to get some of these particles to move by active transport into the plant, so that is going to require energy. So we have active transport from a low concentration of nitrate to a higher concentration within the root. The other example probably that you'll need to know is in the kidney, where in the kidney glucose is actively pumped back into the blood so that it doesn't get excreted. So there it is, that's active transport, movement of particles from a low concentration to a higher concentration using energy, and that's it.